In this video, we are going to discuss about the Cmos devices. On completion of this topic, students will be able to explore the device fundamentals that govern the behavior of the Cmos transistors and VLSI circuits. So first one, CMOS. So CMOS is nothing but complementary metal oxide semiconductor. So this is one of the most popular technology in the computer chip design industry, and also it is broadly used today to form the integrated circuits in numerous and varied applications. So today, our computer memories, CPUs, and cell phones make use of this technology due to the several key advantages. So this technology make use of both p-channel and n-channel semiconductor devices, and in this, one of the most popular MOSFET technology available today is the complementary MOS or CMOS technology. So this is the dominant semiconductor technology for microprocessors, microcontroller chips, memories like RAM, ROM, EEPROM, and application specific integrated circuits. So here this main advantages of this CMOS over NMOS and the bipolar technology is much smaller in the power dissipation. Unlike this NMOS or the bipolar circuits, this complementary MOS circuit has more static power dissipation. Power is only dissipated in the case of the circuit actually switches, and also it can be integrated in most bipolar technology, which has been increased in the performance. So you can see the fabrication process of this CMOS inverter. So first here you can see the NMOS and the PMOS diagram. So first we can see about the NMOS. So in this NMOS, what it happens means NMOS is built on the p-type substrate with a n-type source and drain diffused on it. So in NMOS, the majority of the carriers are the electrons. When the high voltage is applied to the gate, this NMOS will conduct. Similarly, when a low voltage is applied to the gate, NMOS will not conduct. So NMOS is considered to be faster than the PMOS, since the carriers in the NMOS, which are the electrons, travel twice as fast as this holes. So that is given in this diagram. And in the case of the PMOS, so P-channel MOSFET consists of the P-type source and the drain diffused on a N-type substrate. So the majority of the carriers are the holes. When a high voltage is applied to the gate, this PMOS will not conduct. When the low voltage is applied to the gate, this PMOS will conduct. So this PMOS are more immune to noise than the NMOS devices. And you can see the working principle. So in CMOS technology, both N-type and P-type transistors are used to define the logic functions. So the same signal which turns on a transistor of one type is used to turn off a transistor of the other type. This characteristics allows the design of the logic devices using only simple switches without any need of this pull-up resistors also. And in this CMOS, logic gates has N-type MOSFETs that is arranged on a pull-down network between the output and the low voltage power supply rail. So instead of this low transistor of the NMOS logic gates, this CMOS logic gates have the collection of the P-type MOSFETs in the pull-up network also, that is between the output and the high voltage rail. So you can see here, if both the p-type and the n-type transistor have their gates connected to the same input, the p-type MOSFET will be on when the n-type MOSFET is off, and it is vice versa. So this networks are arranged when it is on or off if any input pattern is given. This CMOS can offer very relatively high speed, low power dissipation, high noise margin in both the states, and also it can operate over a wide range of the source and input voltages when we are giving the source voltages fixed. Furthermore, if for a better understanding of this complementary metal oxide semiconductor working principle, we have to discuss the brief CMOS logic gates. So which device we can use as CMOS means the technology like CMOS, which is used in the different chips like microcontrollers, microprocessor, static RAM, other logic digital logic circuits. So where here we can use the different chips like CMOS. So this technology is used in the wide range of analog circuits, which includes the data converters, image sensor, and highly incorporated transceivers for several kinds of communication. So next one is CMOS inverter. So this inverter is consisting of a PMOS and NMOS FET. So the input A serves as a gate voltage for the both the transistors. The NMOS transistor has an input from the VSS and ground, and the PMOS transistor has input from the VDD. So this terminal Y is output. When a high voltage VDD is given at the input terminal of the inverter, this PMOS becomes an open circuit and NMOS switched off so that the output will be pulled down to VSS. So you can see here, when a low level voltage VDD is less 0 volt, the NMOS switched off and the PMOS switched on. And CMOS NAND gate. So in this diagram you can show the two input complementary MOS NAND gate. It consists of two series, that is NMOS transistors between Y and ground, and two parallel PMOS transistors between Y and VDD. So if either input A or B is logic 0, at least one of the NMOS transistors will be off, breaking the path from Y to ground, but at least one of the PMOS transistors will be on, creating a path from Y to VDD. So here the output Y will be high if both inputs are high, both of the NMOS transistors will be on, and both of the PMOS transistors will be in off state. Hence this output will be logically low. And if you see the truth table means, if 0 0 the pull down network off, pull up on, and output will be 1. 0 1 pull down off, pull up on, and output 1. 1 0 means pull down off, pull up on, output 1. 1 1 means pull down on, pull up off, and output is 0. In the case of CMOS OR gate, as two input NOR gate, that is NMOS transistors are in parallel to pull up the output low when either this input is high. This PMOS transistors are in series to pull the output high when both the inputs are low. So this output is kept as floating. And if you see here the truth table, A, B, that is two inputs, 0 0, output is 1, 0 1 0, 1 0 0, 1 1 0. Quiz questions on the introduction to Cmos devices. What are the necessary conditions for the different regions of operation in the Cmos inverter? Thank you.